Hi guys, Mrs. Tilisin here. Welcome to another lesson of Algebra 2. Today's lesson is properties of logs. There are a lot of them, but then we're only going to be learning at least the first 5 or the basic properties of log. Okay, so learning objectives, I will learn how to utilize the 4 basic properties of logs. I will learn how to utilize the power properties of log, and I will learn to utilize common log and the change of base formula. So we now wish to study ways that we can manipulate and combine logs together. First, the 4 basic properties to know well are this one. So we have number 1, log with the base of b. Right now, of course, that letter b in there, let me highlight that. This letter b in here can be changed to any kind of number. So that could be a base of 5, a base of 6, a base of 10, or whatever. Okay? And then if the x value, that is not replaceable, of course. If you have whatever that, number 1 means that whatever kind of base you have, for as long as you have a 1 inside the parenthesis, right? If your x is 1, the answer to that is 0. So let's have an example to match with this property. So property number 1. So if you have a log with a base of 5, then you have a 1 inside the parenthesis, the answer to that is 0. So also, still, property number 1, if you have, like, let's say, change the base to 6, but then still your parenthesis is still 1, the answer to that is, again, a 0. The idea is, because if you want to rewrite this log function into an exponential function, this would be, let me put that in red, this would be 6 to the power of 0. And any number raised to the power of 0, isn't it 1? Right? So that's the property, that's the idea of this property. Okay, so then again, whatever this value is, for as long as we have 1 in this parenthesis, the answer to that is just 0. Okay, property number 2. If the base in your x value, the one inside the parenthesis, are the same, the answer is equal to 1. So let's have that property. So for example, you have log with a base of 5 and 5. The answer to that is 1. Another example would be log with a base of 6. The answer to that is again just 1. And that is property number 2. Let's go on property number 3. So property number 3, it is like, it's the same as number 2, but take a look, it now has an exponent of some kind, right? So what that means is, if you have log, let me do 5, and then let's say you have a 2 as an exponent. So the answer to here is whatever the exponent is. So still on a property number 3, if you have log with a base of 6 to the power of, let's say, 3, then the answer to that is the exponent, which is a 3. Okay, and that is your property number 3. Okay, so last property in this list, let us do property number 4. What does that say? If the base is raised to a power of log, so if a certain or a random number is raised to a power of log, and then take note, this base over here must match with that b over there. When that happens, the answer is just x. So let's put that property. So if you have, say, a random number, 3 to the power of log with a base of 3 and 6, so the answer to that is 6. Still property number 4, if you have, say, 4 to the power of log with a base of 4 of, let's say, 10, then the answer to that is 10. Okay, so for now, I'm going to asked you to circle, whenever we see this property, we circle them and then we name them property 1, property 2, 3, and 4. So let's have our first example over here. Example number 1. Evaluate 7. Let me make it smaller so we can see the property. There you go. 7 times log with a base of 4, right, of 1 in the parenthesis, plus 6 with multiplied with log with the base of 4 of 4. So let us see if there are something familiar in here, like is there a property that looks familiar? So I'm going to circle when I see it. So it looks like this property over here is familiar. And again, I didn't circle the 7 because if you notice in here, none of these log, it's just log. There's no number in it, right? So I'm going to exclude the 7 on it. I'm going to circle log with a base of 4 of 1 because it looks like property number 1. Right? Does that make sense? And then on the other side, I'm going to circle this right here because this one looks like property number 2. Okay? So now that I have property 1 and property 2, I can now substitute the value or the answer to it and solve for the rest of them. So I have 7 times rule number 1, that is 0, plus 6. Rule number 2 is equal to 1. So this is just 0 plus 6. So the answer to this problem is just 6. Okay? Not that bad, right? Okay, moving on. Let's try to evaluate number 1 over here. So the first step we have to do is to see if the rules are applicable to the problem we have. So it looks like this one seems familiar. Right? It looks like this is rule number, so hopefully you guys go back on your own. It looks like this is rule number 2. And then this looks like rule number 3. Okay, does that make sense? Rule number 2 and rule number 3. Rule number 1 says that the answer is just, looks like rule number 1. The answer is, rule number 2. Rule number 2 shows an answer of 1. So going back here, this is going to be 4 times 1 minus 2 times. Rule number 3 has an answer of whatever the exponent is, which is 3. So this is 4 times 1 is 4 minus 2 times 3. Or negative 2 times 3 is 6. So our final answer over here is negative 2. Okay, there you go. Moving on, letter B. Let us circle. It looks like this is property or rule number. Usually I call it rule, but it's actually property. So this one is property number 1. And it looks like this one is property number 4. Okay? So this is 9 times plus 3 times. So let's take a look at rule number 1 and rule number 4. So let's moving back over here. Rule number 1 says that the answer is 0. Rule number 4 says that the answer is whatever is inside that parenthesis. So let's go to rule number 1. The answer is 0. Rule number 4, the answer is whatever that is inside the parenthesis, which is 6. So this is 6 right here. So this is 0 times, hello. Why did I put 3 in there? Sorry. So this is plus 6, not 3 times 6, plus 6. So this is, because this one whole entire thing is one property number 4. So this is 0 plus 6, and the answer to that is 6. Okay, there you have it. Moving on, the power property of log. Although this is not really, there's no number on it in here, but let's call this one property number 5. Okay, so we have 1, 2, 3, and 4, and then we have a property 5. Let b and x be a positive number, where b is not equal to 1. Let p be any real number. So we are introducing a new letter. We now have, earlier we had a y, x, and we have a new letter p. Okay, so let's take a look. Then log with the base of b times x to the power of p became p times log with the base of b times x. What happened to the p? Okay, so it looks like this property says that you can take this exponent and put that on this side. Okay, so the power property of log essentially says that we can take an exponent that belongs to the argument of a log and move, take note of the word, move it in the front of the log. We can also reverse this process and take the number in front of log and move it so it becomes the exponent of the argument. So let's have like an example. Let's say I have log with a base of 6 of, say, or we can even use x or whatever that is, to the power of 7. Okay, what that says is I can take the 7 and put that over here. So I can rewrite this as 7 times log with a base of 6 times x, or of x. Does that make sense? Okay, now let's take a look at some of the examples here. We have here given that what log base 2 of x is equal to 4.1 and log base 3 of y is equal to 5.3. So we're going to evaluate this using the property number 5 that we have learned. It says that we can take the exponent and put it right in front of the log. Okay, same thing with letter B. I can take the exponent and put it right in front of the log. Okay, so I'm going to rewrite this as 3 log base 2 of x minus 4 log base 2 of x. So we are subtracting this and this. Okay, but what do you notice? Do you notice that both the log over here, this term, they're the same, aren't they? Right? We call them like terms. So think of it as 3x minus 4x. Right? If that was a 3x minus 4x, we would have to say, okay, the answer is just a negative x. Right? So I can subtract these two numbers because these are like terms. So I can just say 3 minus 4 is a negative 1 log with a base 2 of x. And we were told earlier that the log base 2 of x is equal to 4.1 right here. So I can solve this further by saying this is negative 1 and that's 4.1 and the answer is negative 4.1. There you go. If I was too fast, of course, you can actually rewatch the video. And that's the good thing about having a video, yeah, because you can rewatch this over and over again. Okay, so let's move the 4. So this would be 4 log with a base of 3 of y plus 6 log 3 with a base, not with a base, of y. So it looks like in here we have again like terms, right? So I can freely combine my 4 and 6. So 4 plus 6 is 10 log with the base of 3 of y. And we were told in the problem that this log base 3 of y has a certain value, which is 5.3. So I can further solve this as 10 times 5.3. And that is equal to 53. So, Miss, how did you know that this log with a base of 3 of y is equal to 5.3? It was given in the problem. Like, Miss, how do you know that log with a base of 2 of x is equal to 4.1? It was given in the problem already. Okay? All right, moving on. There you go. Most often in math and science, there are two specific bases that are often used with log. One of those bases is 10. We see this so often that sometimes we simply leave off the base 10 when writing logs. So base 10, we call that common log or common logarithms. Base 10 logs are called common logarithms. Common logs are usually written without the subscript 10. So that is, like say for example, I have a log base of 10 of x. Because it's just 10, I don't have to write it down. So if I see something like log with no base, right, like you can't see the base of x, that is automatic that the base of that was a 10. So unless it's written as a different number, if it is not written, that means the base of that is 10. That's what we call common log. Okay, recall in exponentials 2.2, the previous lesson, that we saw that some calculators may not be able to evaluate logs when we have to specify the base b. These calculators do have a log button, however, but that log button is specific only to base 10 or what we call the common log. On some models, we may need to type in the argument first, then press the log button. On other models, we may need to press the log button first, then input the argument. So we're going to practice how you would put that in the calculator. So can you try to solve and see if you will get these answers? So you're going to solve, let me make that bigger, log of 32. So sometimes your calculator will be, you press 32 first, and then you click log. And then you should, if you get this answer, then you're good to go. Now, other calculators, you can press log first, and then press 32, and see if you get this answer. Other calculators, it will have like something like this. In those cases, you put a 10 on there, and you put a 32 in there. And you should again get 1.5051. And also try log of 121. So again, you can, depending on what calculators, you put 121 first and then you press log, or you press log and then press 121. Okay? All right, now that we know how to do that, let us move on. And again, you can also, some calculators make you put your base, and the base of that is going to be 10. Okay? So let's practice. So we are going to rewrite this using the change of base formula, and we are going to evaluate this. Luckily, if you have a graphing calculators or like those high-end calculators, you are able to put this exactly as is. Like you can just say, you will have like log in your calculator, okay? You have log, you have a square and a square, where you can put 7 and 52. Unfortunately though, if you're using your phones or your like those small calculators, you are not able to just put this one in. So how do we put that in our calculator? We will solve it like this. So we'll solve it as log of 52 over log of 7. Okay, so the one in the parenthesis goes on the top, and then divide by your base. So you will exactly do this in the calculator. Depending again on the calculator, you may need to type 52 first and then do log. So in the calculator that I'm using, I am able to do this, right? But if your calculator can't do that, so you'll have to solve it as log 52. So you'll actually have to do 52 and then log, and you would have to type every single number, no rounding, every single number that you see that comes out in your calculator. Over you do log of 7 and write every single number that you see, and then the answer to this is going to be, you can now round to 4 decimal places. Okay, there you go. If you need help with your calculator, of course, I'm going to cover that one during class. So this one, again, if you have those high-end calculators, you can input this as is. But if you don't, then you're going to have to do log of 4.2. Or you don't even have to put parentheses. Log of 4.2 divide by, you can put parentheses if you want to, log of 2.5. And again, whatever you see in the calculator, do not round them. You have to write every single number that you see in your calculator. Hopefully, I did not miss any number. And then, of course, for your final answer, you can round it into a 4 decimal places. Okay, there you have it. And that is it for today. I hope you are able to rewrite or know how to rewrite exponential functions to log functions, know the 5 properties, and then actually solve them also in the calculator. Thank you, everyone. If you need help, please let me know. And thank you for listening. And please make sure to do your homework. I'll see you guys in the next video. Bye.